Hello everyone. Today I would like to demonstrate the working of Pspice software by showing you how to implement and simulate the fundamental digital circuits like AND gate, OR gate, NOT gate, NAND gate, XOR gate, XNOR gate. Assuming that everyone knows how to handle the Pspice software, I would like to demonstrate the simulation of these basic gates. I have created a workspace as you can see here by the name my work in this D drive, and the output folder wherever the whatever the circuits that I design, those circuits will be stored under this location. This is the workspace. Under this workspace, and I'll be drawing all the schematics and then simulating them. Okay, first of all, what I need to understand is, in order to have the digital circuit simulation, fundamental digital circuit simulation, I need to know the IC numbers, because this software will not give you the basic gates by the name AND or XOR. Rather, this software will provide these ICs with the IC number, the manufacturer number. For example, if you want to have an AND gate, logic gate, that AND gate comes with an IC number 7408. That I need to understand before looking for the ICs, before looking for the logic gates in this particular software. As you can see here, I can get any IC or any component in this software by clicking on this get new part. Once I click on this get new part, in this window you can see there are different numbers. If I click on to some number, let's say I have clicked on 7404, in the description it is showing it as an inverter. In order to simulate the basic gates, as inverter is a basic gate, I'll choose that. I have selected 7404, the description is an inverter, and then I need to click on place. This is a simple inverter I have got. And the next thing what I want is an AND gate. AND gate IC number is 7408. Once you click on this number, in the description it shows 2 input positive AND gate. I'm going to place that also over here. Next, what I need to have is OR gate. OR gate number is 7432. I can scroll down and search, or I can directly write the number 7432. If I write 7432 over here, part number, it shows 2 input positive OR gate. I can place that over here. Next thing is I need NAND gate, NOR gate. NAND gate is 7400, 2 input positive NAND gate. I'll place NAND gate also. And NOR gate is 7402. You can see positive NOR gate. I'll be placing over here. Let me enlarge so that it is perfectly visible. Okay, after this, if I use this option fit to zoom, whatever the circuit that I have designed will be automatically adjusted to the display. Now, as you can see, the IC number is written with respect to the gates. This is your NOT gate, its IC number is 7404. This is AND gate, IC number is 7408. That means to say, AND gate comes in an IC by the name 7408. Likewise, OR gate 7432, NAND gate 7400, and NOR gate 7402. Now I have got all the gates. Now the next thing is there are inputs and the outputs. I need to provide inputs as well as outputs in order to simulate it. In order to give the input, I'll go to this get part and simply I'll write digis stim. You can see over here, digistem is a source which can stimulate the digital circuits. This is what I'm going to take. Digistem. I'll be requiring two inputs, so I'll be placing two digital stimulus. As you can see, I'll separate it out. There are two inputs that I have taken, digistem 1, digistem 2. All these gates requires two inputs except NOT gate. For that, I'll make the connections like this. In order to do the connections, you can click on this draw wire. From where you need to do the connection, just this is how the connection is made. The first one. Similarly, I'll connect all the inputs of all the gates. Likewise, I'll take the second input, second digital stimulus, and then I'll be connecting to the another input of the AND gate, another input of the OR gate, another input of NAND gate, another input of NOR gate. All the gates inputs has been connected by digital stimulus 1 and digital stimulus 2. I'll be connecting the digital stimulus 1 as an input for the NOT gate. Now what I'll do, instead of calling digital stimulus 1 on digital stimulus 2, I'll rename it as A and B. In order to rename, just double click in the package reference designator, you change whatever the name that you want to give. As you can see over here, the name of the digital stimulus has been changed to A and B. Now what I'll do, after giving the inputs, I need to check the outputs of these gates. In order to check the outputs, I'll go to this get part, get new part, and I'll check if out. There is an option in this part browser, if out and if in. I'll be taking if out and I'll be placing one output for each gate. And then I'll be making the connection by drawing the wire. This is the output of NOT gate, this is the output of AND gate, this is the output of OR gate, this is the output of NAND gate, and the final output is NOR gate. As you can see, the output does not have any name. In order to give the name, just double click on it and type not underscore out so that it would be visible properly and it is user understandable. Second output I have mentioned as AND out. Third gate output I'll mention it as OR out, or underscore out. And the fourth gate output I'll mention as NAND underscore out. And the fifth gate output I'll mention it as NOR underscore out. Now, what I have done till now is I have taken all the basic gates by choosing the respective IC number, and then I have applied the inputs, that means the stimulus, digital stimulus A and B, and then connected to all the inputs of the basic gates, and I have taken if out in order to measure the output of the digital logic gates, and then connected to the respective outputs of the logic gates. Now the question comes, I need to apply the stimulus, that means I need to trigger this system. In order to trigger the system, just I need to do double click on the stimulus, a pop-up window opens, I need to save it.